February 3rd. 1 a.m. Location: Toronto Pearson International Airport. Runway 24L, a runway 4 kilometers long and 60 meters wide, capable of handling wide-body aircraft at full gross landing weight. The runway is not fully visible at the moment. 17 centimeters of snow have fallen in 5 hours. It's still snowing. A 34-knot wind blowing from the northwest is sweeping the snow horizontally across the apron. 3 holding aircraft are circling at 6,000 feet, awaiting a clearance that has not yet been issued. An Oshkosh H-Series twin-engine snowblower just made its first pass down the runway. The machine's head, a 59-inch blade driven by a 670-horsepower Scania engine running at full throttle, is blasting a continuous stream of snow 60 meters beyond the runway edge lights. The second machine follows in perfect formation, 400 meters behind. This is the sequence of operations required to open the runway, and they have exactly 20 minutes to succeed. Yes, just 20 minutes. Transport Canada grants the airport operations team exactly this amount of time, from the moment they decide to clear the runway until the runway must be declared open for landing. In the coming minutes, we'll take a behind-the-scenes look at Canada's most challenging airport snow clearing operation. The machines, the sequence of operations, the engineering that keeps an airport serving 50 million passengers running during a Canadian winter. The runway doesn't care that it's 1 a.m., neither do the machines. If you're ready, let's begin. If you enjoy watching real heavy machinery, like bulldozers, excavators, and the machines that build the world around us, in action, hit that like button. And if these kinds of machines have captivated you as much as they have us, don't forget to subscribe to the channel. It's a small gesture for you, but a huge support for us. But we'd also love to hear from you. Have you ever worked alongside heavy machinery? Have you operated this kind of equipment? Have you seen these machines on a construction site? Tell us in the comments. Many of the best stories in this community come from people who've actually experienced these moments firsthand. Now let's get back to the story. But to understand how this operation unfolded, we have to go back. Toronto Pearson International Airport is the largest and busiest airport in Canada. It handles more than 50 million passengers per year across 6 runways and 2 terminals. In the global network of aviation, Pearson is a critical hub, the point through which Canadian and international traffic flows on routes connecting North America to Europe, the Caribbean, and beyond. When a runway at Pearson closes, that closure does not affect only Pearson. It ripples through the entire North Atlantic flight network. Aircraft divert to Buffalo, Detroit, or Montreal. Gate holds Cascade. Passengers miss connections across 4 continents. Winter at Pearson is not an occasional challenge. It is an operational condition that the airport manages continuously from November through March, sometimes into April. Toronto sits in a climate zone where lake-effect snow from Lake Ontario can drop 30 to 50 centimeters in a matter of hours with almost no warning. In a single winter season, Pearson can receive over 130 centimeters of snow. This is why the airport's snow removal fleet is not just large, it is orchestrated. The fleet operates under Transport Canada's TP312 airport standards, which specify runway clearance times, friction threshold requirements, and equipment specifications that must be met for a runway to be declared open. The friction standard, measured with a specialized friction testing vehicle, determines whether an aircraft can brake safely to a stop on the declared runway surface condition. Below a certain friction coefficient, no aircraft can land. The clearance sequence is not just about removing snow. It is about restoring a surface that meets a specific engineering specification, under time pressure, in conditions that are actively working against you. And every minute of that 20-minute window is allocated in advance, not estimated. Allocated. The Oshkosh H-Series is the machine that makes the 20-minute window possible. It was purpose-built for this exact application. Not adapted from a construction chassis, not modified from a commercial truck platform, but engineered from the ground up for airport runway clearance. Oshkosh Corporation has been building heavy-duty all-wheel drive snow removal vehicles for over 80 years, and the H-Series represents the current pinnacle of that lineage. The dual-engine blower configuration carries two completely separate power systems. The drive engine propels the machine down the runway at operating speeds of up to 35 miles per hour. The blower engine, a Scania DC-16 producing 670 horsepower at 1,800 revolutions per minute, drives only the blower head through a dedicated mechanical driveline that is completely isolated from the vehicle's transmission. This separation means the operator can manage blower speed and vehicle speed independently, optimizing snowcast distance and throw velocity for the specific material being moved. The blower head itself is a two-stage system. The first stage is the auger ribbon, a helical steel screw running the full width of the machine intake, which gathers and concentrates snow from the runway surface into the central feed position. The second stage is the 59-inch, 5-bladed impeller, which accelerates that concentrated snow through the discharge chute at velocities capable of throwing it up to 60 meters clear of the runway edge. The H-Series cab was designed specifically for the airport operating environment. A panoramic windshield, 40% more glass area than a conventional vehicle, eliminates corner posts. Lower front windows give the operator a direct sight line to the edge of the blower intake. Rear and side cameras cover the zones beyond sight lines. A second full seat accommodates a training supervisor or safety observer. In a blizzard at 1 in the morning, visibility from this cab is not just comfortable, it is what keeps the machine on the runway. The Oshkosh blower is the centerpiece of the clearance sequence, but it does not work alone. At Pearson, a full runway clearance deployment involves a coordinated formation of up to 8 or more vehicles moving in staggered sequence down the runway, each one assigned a specific task in a specific position, timed to millisecond precision. The sequence begins with the lead plow, typically a large tandem truck fitted with a front pusher plow and a wing plow that can span a full 20-foot width, making the first break through the deep snowpack. The lead plow does not attempt to remove all the snow. It displaces it, breaking the compressed layer and pushing accumulated windrows toward the runway edge. The blower follows, working in the cleared channel opened by the plow. The blower's job is total clearance, not just surface-level visibility, but the actual removal of snow and ice from the runway surface to a depth that allows the friction measurement vehicle to get a valid reading. Behind the blower, the broom. The Oshkosh H-Series XF front-mounted broom, powered by its own 500 horsepower engine, sweeps the residual snow and slush that the blower's intake cannot capture. The broom's contact pressure on the runway surface is adjustable, allowing it to polish the cleared surface without damaging the runway lighting infrastructure. An anti-icing or de-icing truck may follow, applying a liquid treatment to prevent bond formation between residual moisture and the concrete surface. Finally, if the friction testing vehicle makes its run, recording friction data at regular intervals across the full runway length, uploading the results to the operations center in real time. The moment the friction coefficient meets the Transport Canada threshold, the clearance is declared. The runway reopens. The aircraft descends. The scale of snow removal operations at a major Canadian hub airport like Pearson cannot be reduced to a single machine or a single event. Pearson maintains a snow removal fleet that operates around the clock through the winter season. The fleet includes not just runway clearing blowers and plows, but specialized equipment for every surface type on the air side. Apron sweepers for aircraft parking areas, taxiway clearing units, shoulder maintenance vehicles, and airfield grader machines like the Caterpillar 163H with its 220 horsepower engine and 14-foot mold board, for grading and leveling accumulated snow along airfield shoulders and blast pads. The operation is structured in priority zones. Runways in active use are the highest priority, cleared first, held to the tightest friction standards, inspected most frequently. Taxiways are secondary, cleared to allow safe aircraft movement between runway and gate. Aprons come third. In a sustained winter event at Pearson, the snow removal operation can run for 48 or 72 continuous hours. Operators rotate through shifts, but the machines do not stop. The fleet is designed to be maintained in the field. Fuel trucks circulate through the active fleet, topping up tanks without requiring vehicles to return to the maintenance hangar. Mobile maintenance units carry critical parts and hydraulic tools for on-site repairs that would otherwise pull a vehicle out of service during a critical clearance window. The operational language at Pearson during a major snow event is not about managing the storm. It is about staying ahead of it. The machines run faster than the snow falls, or they try. The machines provide the power. The system provides the sequence. But the people running it provide the judgment. Airside snow removal at a major Canadian airport is one of the most technically demanding heavy equipment operating roles in the country. Operators must hold airside vehicle operation permits specific to the airport, pass recurrent training on runway incursion avoidance, demonstrate competency on each vehicle type in the fleet, and maintain radio communication discipline with the Airport Operations Center and Air Traffic Control throughout every clearance pass. The Operations Center runs the clearance sequence from a live display showing the position of every vehicle on the airfield surface at all times, using GPS transponders on each machine, updated every few seconds. The coordinator tracks the formation timing, monitors friction data as it comes in from the testing vehicle, and maintains communication with the tower regarding held aircraft status. The moment the friction reading meets the threshold, the coordinator calls the runway available. That call goes to the tower within seconds of the reading being confirmed. The tower clears the holding aircraft. From the perspective of the passengers on those planes, who have been circling for 20 minutes watching snow fall through the porthole window, what just happened is invisible. The flight attendant picks up the intercom and announces the approach. Below them, the Oshkosh blower is already repositioning for the next pass. The next clearance window will be in about 45 minutes, because the snow has not stopped. When runway 24L at Pearson is declared available, the 3 aircraft that have been holding descend in sequence. The first touches down inside the next 4 minutes. The second follows. The third lands 12 minutes after the runway reopened. The immediate result, 3 aircraft safely recovered, 600 passengers delivered, connecting flights made. The broader consequence is what that recovery means at scale. Pearson processes tens of thousands of passengers on a heavy winter day. When the snow removal team keeps the runways open, and they do, through events that would close airports in other countries, the Canadian aviation network holds together. The long-term impact of machines like the Oshkosh H-Series has been consistent. Airports in climates like Canada's are able to operate through conditions that would have forced seasonal shutdowns a generation ago. The mechanical capability of the fleet has outpaced the weather. The modern relevance is about what comes next. Us Oshkosh and other manufacturers are developing autonomous and semi-autonomous airport snow removal vehicles, machines that can execute clearance sequences with human oversight, but without a human in each cab. Formation coordination via GPS, proximity detection, and automatic speed modulation are all technologies in active development and early deployment. The 20-minute window will not change. The machines chasing it might. If this story meant something to you, consider subscribing to Machine Geek Canada. This channel exists because people who appreciate these machines keep coming back and sharing their experiences. And if you've ever worked around heavy equipment, bulldozers, excavators, demolition machines, tell us your story in the comments. What machine did you operate? Where did you work? What was the toughest job you ever faced? Many of the most powerful stories come directly from the people who have lived them.